This example of computing a correlation looks at the relationship between the number of kilometers run per week and a runner's marathon finish time in minutes. What you're seeing are the original values in the first two columns, and in the columns labeled ZX and ZY, these are the z-scores. ZX gives the z-scores for the kilometers per week. These were computed in the previous example on z-scores. This fourth column lists z-scores for the marathon finish time in minutes. These were also computed earlier in the demonstration on computing z-scores. Once you have the z-scores, it's very easy to obtain the correlation coefficient. The first thing you want to do is simply multiply the two z-scores. So I'm going to take negative 0.8731 and multiply it by 1.7488. And with that I get negative 1.5269. I'll do the same thing. I'll multiply 0.0333 times negative 1.7254. And the result is going to be negative 0.0575. After multiplying the two z-scores, what I need to do is add them up. When I add up this last column, I get negative 2.8394. Now the last step in computing the correlation is to just divide that result by n minus 1. And the result is negative 0.4056. The relationship between the kilometers run per week and the marathon finish time in minutes is a moderate correlation of negative 0.41. We can use simple regression to look at the way the kilometers run per week predict marathon finishing times. The prediction equation is here, where y prime is the marathon finishing time that's predicted. A is an intercept coefficient, B is a slope coefficient, and X is a value of the kilometers per week. Since we've already computed the correlation between these two variables, all we need are some summary statistics to complete the simple regression between them. For example, all you need to know are the mean and standard deviation of each variable and the correlation between them. To get the slope coefficient, we simply need the correlation, negative 0.4056, and the ratio of the two standard deviations, 10.65, and 18.754. And with that, we get a slope of negative 0.2303. What the slope coefficient means is that for every 1 kilometer increase in weekly running distance, we get a reduction of 0.23 minutes in marathon finishing time. Now that we have the slope, we can compute the intercept, and that's going to be the mean of y, which is 197.375, minus the slope, negative 0.2303, times the mean of x, which is 67.375. And with that we get 212.8915. Our prediction equation then is going to be 212.8915. It's going to be plus a negative, so I'm just going to write minus 0.2303 times x. Now all we need to do is plug in a value of x, and I'm going to get a predicted marathon finishing time. Suppose I want to see what my predicted marathon finishing time is going to be if I'm running 40 kilometers per week. My predicted marathon finishing time is 203.68 minutes, which turns out to be about a 3 hour and 23 minute marathon.